Welcome to the deep dive. And, when you picture the future of farming, you probably imagine, I don't know, a massive chrome-plated robot tractor.
Right, yeah, or like fleets of drones flying over a cornfield. We always look for the hardware.
Exactly. But the actual revolution, the thing that is fundamentally rewiring our global food supply right now, isn't something you can even see. It's an algorithm.
It is. We're seeing a complete shift from physical brute force to just supreme information processing.
So today, our mission is to peel back those sci-fi tropes. We're looking at the invisible, really high-stakes data war happening right in the dirt and up in the cloud.
And we're pulling from some really fascinating sources for this.
Yeah, the foundation for today is this brilliant piece by AI thought leader Johan Steyn. It's called Farming's Becoming a Game of Timing, and AI is changing the odds.
He really nails the core issue, and he references a bunch of key data points we'll get into, like a February 2026 Reuters report on South African droughts.
Plus a massive Google AI case study from India, a phys.org piece on weather models, and some really telling insights from Farmers Weekly. So lots of ground to cover.
Oh, absolutely.
Okay, let's unpack this, because you listening right now, you might live in a city. You might not have stepped foot on a farm in your entire life.
Most people haven't.
Right. But you need to care deeply about this topic because the margin for error in this industry, it directly dictates your grocery bill. It dictates whether the food is even on the shelf next month.
Yeah, and the baseline reality we have to establish before we even touch the AI is just the sheer volatility of farming today.
It's intense. Reading through these sources, I realized modern farming sounds less like traditional agriculture and more like day trading stocks.
That's a really good way to put it. Historically, a farmer relied on generational knowledge. You planted in a specific week of spring because your grandfather planted in that week.
Right. The climate was basically a reliable partner.
Exactly. But that partner has become incredibly erratic. You are making massive, highly leveraged bets against a chaotic market. And in this case, the market is the weather.
But if a day trader messes up, they lose a financial portfolio. If a farmer mistimes the market, they lose a season's worth of food.
Which is why farming today is almost entirely about timing under deep uncertainty. It's no longer about executing a perfect, rigid plan.
Because the cascading costs of bad timing are just brutal. Steyn outlines this perfectly. Say you decide to plant your seeds too early.
Right. You get hit by an unexpected heat wave or a sudden dry spell.
And the seeds just fail to germinate. You've buried all that money in the dirt for absolutely nothing.
But then if you react to that fear and hold off, planting too late, you miss the optimal growing window, the soil temperature drops, and your yield plummets anyway.
And then there's the chemical side, like spraying for pests or applying fertilizer.
Oh, yeah. If you spray at the wrong moment, say 12 hours before a sudden downpour, all those expensive chemicals just wash away.
Wasted cash, wasted labor.
And you're potentially contaminating the local water supply without helping your crops at all.
It's just a lose-lose. And Steyn mentions irrigation is maybe the tightest rope to walk.
It really is. Over-irrigate, and you burn through scarce water and the heavy electrical power needed for the pumps. Under-irrigate, and you destroy the crop.
Every single operational choice has a catastrophic downside if you're off by even a few days. And this isn't abstract. We're not theorizing about the year 2050 here.
No, it's happening right now.
Yeah. Steyn points to that Reuters report from February of 2026, severe drought conditions in the Western Cape of South Africa.
We are talking about highly resourced, established farmers who are literally losing their cattle to drought.
And when they lose cattle, the whole local agricultural economy starts to fracture.
Which explains the current mindset of the industry. I mean, look at Farmers Weekly. They specifically made AI and technology a major theme for 2026.
Not because farmers just want to play with new tech toys.
Exactly. It's purely a push for long-term survival. We're moving from reactive farming looking at the sky and waiting for rain to anticipatory farming.
But if the elements are that chaotic, how do you anticipate anything? They don't need a crystal ball. They need better math.
And that is the core value of AI in agriculture. It is not flashy robotics, it is prediction.
Prediction.
Yeah.
Not a guarantee, though.
Right. What's fascinating here is the distinction between prophecy and probability. AI isn't going to promise you it'll rain at exactly 2:14 p.m. on Tuesday.
Which is what a lot of people expect when they hear AI forecast.
Yeah, but what it actually does is offer highly actionable probabilities based on data sets that are just too massive for a human brain or even old software to process.
Let's get into the mechanics of that.
Uh,
Because most people, when they think of AI, they're picturing a chatbot, writing a funny email or generating an image.
right, yeah.
But out in the fields, it's doing something much heavier.
Right.
How does it actually figure out that optimal planting window?
It's all about dynamic weighting. A traditional weather model might look at a cold front moving in and treat that as the main factor.
Makes sense.
But a machine learning model pulls in a vastly more diverse web of signals. It ingests real-time satellite imagery. It reads data from physical sensors buried in the soil, measuring moisture minute by minute.
Wow. So literally tracking the dirt in real time.
Yeah, and then it cross-references all of that with historical weather patterns spanning decades, plus short-term meteorological forecasts.
So it's not just looking at the sky. It's looking at the dirt, the history, the satellite, all simultaneously.
And crucially, it learns how those factors interact in one specific location. Like, it might realize that in your specific valley, the current soil moisture actually overrides the incoming cold front when predicting a frost.
Oh, wow.
It weights the variables dynamically, constantly adjusting what data matters most.
So it synthesizes all those scattered signals to tell a farmer, based on these 10 million data points, your optimal planting window opens in exactly 48 hours.
Exactly. Instead of a vague expectation like expect a dry summer, you get hyper-specific data. You have a 72-hour window to plant before a 3-week dry spell.
The scale of that impact is just staggering. You look at that Google AI case study Steyn highlights.
Oh, the India Monsoon Project.
Yes. They deployed AI-based monsoon forecasting to 38 million farmers.
38 million. The scale is incredible.
I honestly struggle to wrap my head around that because a monsoon is this massive continent-wide event. How does AI give an individual farmer an edge? Like, don't they all know what's coming?
They know it's coming generally, sure. But the exact onset, the local intensity, the distribution, that is incredibly hard to pin down with traditional meteorology.
So the AI models find the exact local timing.
Yes, they analyze the atmospheric data and provide earlier, much more reliable signals about when the rain will hit specific regions.
And for a farmer whose whole livelihood depends on timing their planting perfectly with that rain,
Gaining even a few days of highly probable foresight dictates the entire season. That one piece of predictive data secured planting decisions across a subcontinent.
securing the food supply for tens of millions of people. It's an incredible story. But, throwing complex tech at a chaotic environment can backfire.
Oh, absolutely. It can go very wrong.
Here's where it gets really interesting. Because you can have the most sophisticated algorithm ever, but if the data is bad or the dashboard is a mess, the whole thing falls apart.
The operational friction is immense. Steyn references that phys.org piece, which tackles this perfectly. AI weather models are game changers, but they can be, and this is a great phrase, confidently wrong.
Confidently wrong. Like, it says there's a 99% chance of rain, but it's completely detached from reality. How does an AI get that so wrong?
Well, general forecasts can be broken by local microclimates. The neural networks can hallucinate patterns if their training data lacks local history.
So it might analyze a region and predict steady sunshine.
Right, but it completely misses that a specific 500-acre farm sits in a topographical dip, a little valley that traps cold air and creates unexpected localized frost.
So poor data inputs guarantee poor outputs. If the AI doesn't know the exact shape of that valley, it's not just off a tangent, it's actively harmful if the farmer bets on it.
Exactly. And beyond the data accuracy, there's the issue of technological bloat.
Steyn draws a sharp parallel here, right, to how AI complexity is crippling IT departments in the corporate world.
Yes, and we are seeing the exact same thing on farms. Think about it. A farm adopts 10 different AI tools. One for soil chemistry, a proprietary system for the tractors, a third dashboard for weather, another for pests.
And none of them talk to each other.
Right, they don't integrate. The tools just sprawl out of control and become a massive burden.
It's kind of like having a 50-page, highly technical instruction manual for a fire extinguisher.
That is a perfect analogy.
I mean, it might be the most brilliant engineering manual ever written.
Yeah.
But when a fire starts in your kitchen, you don't want to read a manual. You just need to know where to point the hose.
Delivery is everything. A brilliant forecast buried on page 4 of a clunky laptop dashboard is worthless to a farmer sitting in a tractor in a dusty field.
Right. They need a simple alert.
A trustworthy ping on their phone that instantly changes their behavior, like, stop spraying, heavy rain incoming in 20 minutes.
But wait, a farmer who has worked the same dirt for 40 years, they already know their weather patterns. They literally know the smell of the air before a storm.
They do.
Why would they surrender that lifetime of intuition to a software dashboard?
This raises an important question. It's the ultimate hurdle. The human-computer trust gap. Why should they trust the app over their own eyes?
Yeah, why should they?
Because the brutal reality of climate change is that those 40 years of intuition are becoming less reliable. The historical patterns are breaking down.
So their internal baseline is getting scrambled.
Exactly. The signs they used to read in the soil are shifting. The AI is stepping in to provide a new baseline, but that requires a huge leap of faith.
Deep verification. The AI can't just be installed and blindly followed on day one.
It has to prove itself season after season on that specific farm. Building trust by proving it actually understands the local microclimate better than the old signs.
So if this tech is incredibly powerful, but flawed by bad data and heavily reliant on trust, how do we actually deploy it safely? Sken lays out a practical roadmap in the sources,
He
right?
does, a playbook for the 3 key players. And it starts with the farmers. His advice is, embrace discipline and ignore the hype. Don't try to predict everything at once.
Start small. Focus on a short list of decisions where timing has the biggest financial payoff.
Pinpoint the highest leverage moments, the exact planting window, irrigation scheduling during a dry week. Test the tools against real-world outcomes over a full season.
Right, don't buy into a flashy software demo in an office. See if it actually predicted the frost in your valley better than you did. The goal isn't magical perfection.
No, it's just making fewer costly mistakes than last year.
Which brings us to the tech leaders, the people actually building these tools.
For them, the mandate is avoid tool chaos. Build interoperable platforms. Standardize how data is captured so these apps can actually talk to each other.
Back to the fire extinguisher. Give them the hose, not the manual. Keep the user experience ruthlessly simple.
And explainable. That is crucial for bridging the trust gap. If the model tells a farmer to delay planting by a week, it can't just be a black box command.
It has to say why.
Exactly. Delaying planting due to an 80% chance of sudden frost based on shifting polar winds. If the farmer understands the mechanism, they can trust the tool.
That leaves the third group in the playbook, the policymakers.
If we connect this to the bigger picture, this is the paradigm shift that affects everyone listening. Policymakers have to stop viewing agricultural AI as just a private business tool for boosting profits.
They need to treat it as resilience infrastructure.
Yes, like a seawall or a national electrical grid.
Because when extreme weather hits, a massive regional drought, a sudden flood, it doesn't just isolate one farm.
It devastates an entire region's output. But if that whole region is networked with AI early warning systems, the collective response changes.
Farmers across the state can harvest early or share limited water resources. So what does this all mean for you, the listener?
It means this resilience infrastructure acts as a buffer for the entire food system.
It won't magically stop a drought in South Africa,
No, AI can't stop the weather.
but it acts as a shield against the damage. It's the invisible net that keeps the grocery store shelves stocked and prices from skyrocketing when the climate goes chaotic.
It is becoming the defining mechanism for global food security.
Pulling all these sources together, Steyn's playbook, the Google India study, the stark realities of the drought, the core takeaway is clear. Predictive AI is never going to replace the hard-earned grit of a human farmer.
It acts as an enhancement. It's like a doctor diagnosing a patient. A traditional system just looks at the thermometer. The AI looks at the thermometer, your genetics, what you ate 3 weeks ago, and your zip code to tell you exactly when the fever will break. It tips the odds slightly back in humanity's favor.
Allowing farmers to act sooner and waste far less. But, as this tech scales up, it leaves us with a pretty heavy question to think about.
Yeah.
If these models continue to ingest data and eventually become so precise that crop yields are essentially guaranteed, does agriculture just become a guaranteed math equation?
Wow, if the risk is entirely removed, it kind of stops being a relationship with nature.
Exactly. It becomes a purely financial instrument. And if that happens, who really ends up controlling our global food supply? The people working the dirt or the tech companies running the servers?
That is a fascinating and slightly terrifying thought.
Something for all of you to mull over the next time you sit down to eat. We encourage you to keep questioning, keep learning, and pay just a little more attention to the quiet data war sitting right there on your dinner plate. Thanks for joining us on The Deep Dive.
See you next time.